Hi everyone. I'm going to go through a few videos over the next little bit on how to convert a Homelite weed whacker engine or leaf blower engine or even a chainsaw engine, uh, convert it for RC plane. There's lots of videos on YouTube about them running, some of the stuff guys have done, but there isn't really any videos about what they've done to make them ready to put on an airplane. And I see a lot of videos that, or a lot of comments in videos that people are asking, hey, how do I make this? Hey, how do I do this? So hopefully I can cover some of those. So this will be a few videos based on putting it together, to running it, to maybe taking it apart, checking some things, doing some performance mods like porting some of the intakes, and then seeing what the actual performance gain is, and we'll check some RPMs and stuff like that. So first things first, this is a 30cc. This is one that I got out of a trimmer, and I've already taken all the material off of the crankcase. There generally is a big section of aluminum here that would be for the mounting of this onto the trimmer and or weed whacker, or to the blower, sorry. And so what I've done is I've taken a file and a saw, and you're just gonna remove all the excess. Don't remove into here, into this webbing. This webbing is very important to have for structure. Okay, so if you start removing that, what's going to happen is there's not going to be enough strength for this bearing here, so you'll have failure in there. Another thing too is keep some of the material here, because we're going to be running the flywheel and the magneto, so and the coil, so we need some strength there. So one of the first things you got to do is you got to be able to put a throttle bell crank here, because we don't have an actual easy way to get the carb and the throttle servo hooked up. We need to actually be able to have a push rod in between your carb and your bell crank, and then your bell crank and your servo. So if you look at this engine, this is the 25cc I did last year. I got some other videos, you can see it running up on YouTube. So here's a ball link you can see on the throttle arm. Now, the idea behind that is that from your throttle servo, it's going to move this end, and this end is going to move the carb. So if you come over to this one again, you see, so we're going to make this hook to this one. I still got to finish, but this one's going to hook up like so, and it's going to actuate the carb. So I'll make some more videos once I get that completely finished. Right now what I've done, other than trim all the material off, is I have put the crankcase and the cylinder together, and I've put the piston in there, and I've checked my distance in here with solder. You put the solder into the hole, bend it 90 degrees, and then you're going to turn this, preferably with flywheel on, to get the height of the pistons and the head clearance. You want to try to get about 20 thou. This one was, I think without a gasket, it was about 30, 35, which I'm going to leave for now. I might change that later just to try it. I want to do some base runs with this engine and figure out RPM, what kind of prop it likes, and then once I get a baseline, then I can adjust a few things and we can try it again, and we'll see if doing some of that stuff has a big performance thing, or if it makes the engine run worse. So the next thing that we're going to do is we're going to remove the bolts that come, because they hold the plastic back plate, which is this, but I've trimmed this too. See, this is another thing you gotta trim. This had a huge piece that has cooling holes on the bottom, or on the back of it, for when the flywheel and everything is blowing the air through the cylinder. Now I've trimmed this down to make it nice, get some weight reduction, very important. But it normally is held on with bolts, similar to this. Now what we've done is we've got rid of these because for trying to make this engine as light as possible, because these are heavy engines compared to an actual designed RC engine. So what I've done is I have put these, they're just normal bolts that I've cut the head off of, and I've rethreaded the head end, and these get screwed into your case, and then they stick out. Now what you do is this is going to get bolted on. You can see here I have a normal washer, a lock washer, and a nut. So that is going to be what bolts down this back plate now. And what you do after to mount this to the airplane is you're going to put a penny washer here. And then this is you're going to drill 4 holes in the firewall, and then the penny washer is going to be what spreads the load. And then you're going to have a penny washer on this side, and you're preferably a nylock nut. And then that will keep everything secure, and you're spreading the load, and you're not adding a big plate of aluminum on the back of that. Like a lot of guys add a 1/8 piece of aluminum back here. Problem with that is you're adding unnecessary weight to your airplane. These are already heavy, so we're trying to save weight where we can. The next thing you have to do is from factory, these engines, they have quite a bit of space. You can see here I got a plate here. They have a lot of space between the back plate and your crankshaft. You can see the end of the crankshaft there. So the reason for doing this plate is it's called stuffing the crankcase. So we're trying to get less volume in there. So it helps with secondary compression. The idea is to get it as close to that, but you want to have enough space that when you turn this or things are able to expand and move back and forth, that we're not going to rub on this. You see it a lot on glow engines. They're very, very close to the backplate, and they'll even have a mark here from where it rubs, and that's kind of common with all glow engines. So what I've done is I've taken, I believe this is 1/8 plate, just aluminum, and I've drilled a hole in the center of it, and I drilled a hole in the center of the back plate, and then I countersunk it. And this is just a normal countersunk screw, and then a nylock nut. Okay, very important to use nylock nuts because there's a lot of vibration with these engines. So the next thing I've done is you can use JB Weld, or I like to use a product called 3-Bond, or you can use this. This is another product that I'm trying on this engine. It's basically, it smells exactly like 3-Bond. It looks like 3-Bond, and it's Moto Seal. So this is approved for using on gasoline. Don't use RTVs, don't use silicones, don't use any of that stuff on gas engines. It'll eat it and it'll turn to goo. So as you can see, now we've increased the length of this, getting it closer to the crankshaft. So effectively we've stuffed the crankcase. I'll try to do this with one hand. Just hold on a second. So if you look here, you can see the light in there. It's a little harder to see. I'll try to get closer. See the distance in there? So you want to try to get about 20-25 thou. That'll ensure when things heat up, when things move a little bit, that you're not going to hit the back plate. Because if you start peeling metal off there, that's not a good thing either. So that's one of the mods that you can do. You don't need a special lathe, a bandsaw, sanding stuff. You don't need anything. The only thing I did is I took this back plate, I flipped it upside down on my piece of aluminum, and I just traced it with a felt pen just around it, and then you're left with a very close shape like this. And I just cut it out with a hacksaw, and then I just took a file and I filed it round and then flat to deal with this. And then what I did is I scuffed up both surfaces, cleaned them really good with acetone, and then I 3-bonded it, and then I screwed it on. So a combination of the screw and the 3-bond is going to hold this together, so this will never fail. When you do this to the stock engine, you will have to adjust your gaskets because 1/8 you will rub the back of the crank shaft. So that's why you can see a little bit of, this is when I just mocked up this whole assembly, that it has a little bit where it was touching. So what I did is I made a new gasket here. And this, once again, it's not it's not a manufacturer OEM one. I've made this. So I just, simple way to make gaskets, guys, is if you want to make a gasket for something and you don't have the original, is you take masking tape, and I can make another video if there's a interest for this, is you cover this whole area here, for instance, in masking tape. And then what you do is you trim the inside and do a couple layers of masking tape. And then you trim the inside of all this stuff like this. And then what you do is you trim the holes out. And then you peel that tape off, stick it on your pant leg or something a few times to get rid of the stickiness. And then you're going to stick it onto your gasket material. And then what you do is then you basically just cut around where that masking tape was, and you have a perfectly fitting gasket. Now that's all I did for here is I just put tape, just masking tape. I just laid it all over this open hole here off the back of the crankcase. And then I just cut with a razor blade all the way around here. And I cut my holes out following the hole inside. And then I cut it flush with the top of the crankcase. And that's what we ended up with. This doesn't have to be super perfect, anything like that, because all we're trying to do is space this. We're trying to space everything so that we have our dimensions. Because when I do this too, I'm going to put some of that Moto seal around it just to ensure we have a good sealing surface. They're not really the most accurate engines, so a little bit of sealant's kind of a nice thing on them. This one, you can see this one just had a gasket and it is weeping a little bit. So just to prevent that, I would put a gasket and the Moto seal. Now, moving on to your base, I guess, of where the cylinder sits. In order to bump up compression and increase your import timing, or intake timing, sorry, what you have to do is you have to drop the cylinder. So the cylinder has to, in effect, come lower, and that will increase your intake timing, which is what you want. And it also bumps up the compression a little bit. So without using a milling machine and milling the surface down, you'd have to mill the surface down to get quite a bit more than what I got. I'm just going to leave the gasket out, and I'm going to use the Moto seal, and I'm going to apply a very, very thin bead of it on this. Now, that works, but you have to be very, very careful. It's going to help me get some of my increase in intake timing. It's going to bump up the compression. But what you can do too is you can have a problem in that you get sealant inside this little hole. Now this hole is what actuates your carburetor pump. So if you plug that hole, now your carb's not going to suck fuel. So using sealant is awesome, but you have to be very careful and very, very stingy with it. So when we mate these surfaces, I may stick a little piece of wire or even mount this with the sealant like so, and then I'll take my little compressed air nozzle and I'll give that a little bit, just a little shot of compressed air, and that'll blow anything. And I'll just keep a rag on the inside here, right where you can see that slot here, right here. I'll keep it inside here so that if any of the sealant got into this hole, it'll blow it into the rag. And then that way we don't need to use a gasket, and we've eliminated, here I'll show you the gasket, we've eliminated the thickness of the gasket, which in effect has done a bunch of things for us that will help us with power. So here's the gasket. I forget what thickness it is, but it's probably enough to add 5 degrees of timing, which is awesome. The only negative effect of that is that when you lower the cylinder, because the intake is open and closed with the bottom of the piston, and the exhaust is open and closed with the top of the piston, it'll change the timing here too. And what it does is, because we're lowering it, this is now going to open later. So we don't really want that. We want to try to maybe restore that. So that'll be some of the next videos where I might take this. It's hard to see in here. I don't have a light. But we'll try and port this. We'll port the top. You always port the top of the exhaust. And if you're going to port the intake, you always port the bottom. Okay? And when you do that, you got to be very careful, because what you remove affects opening and closing. Because unlike a 4-stroke engine, the piston's movement is determining our timing. So if there is interest in some of those videos, we can do that. I have a few other engines that I'm gonna get ready to run on some on some planes and on a test bench. So that's a couple things with the cylinder and the crankcase. I'm just gonna try it like it is right now and get a base run. This one doesn't have very much time on it, and it has basically, I would say, new compression. I'm not changing the rings or anything like that. So it should have a power gain, and it shouldn't have that much power loss by not messing with the port timing yet. When I measured the timing, I have 120 degrees for my intake, or 125, sorry, for my intake timing. And this is total timing. And here for my exhaust, I have 153 or 154, which, having lowered this a little bit, it still is very good. I might increase that a little bit, but that's pretty much in the ballpark of where you want it. This, on the other hand, the intake, ideally it would be better if we even had another 10 degrees additional on what we had. So for somewhere in the 135, that would give us a little bit more power. I'm going to probably try that, but we'll see how it does with some of the props that I have, and then we'll make a decision. So we've covered the cylinder, we've covered the crankcase, we've covered this. Some of the later videos, I'll explain another thing you can do inside this cylinder. If you have access to a milling machine, or you want to try to remove some of this material to increase compression even more, we can go over that stuff at a later date. So just moving this aside, the next big problem that most of the people have with trying to convert these, or Ryobi, or any of these weed whacker engines, or leaf blower engines, or anything like that, is that you need some way to mount a propeller. Now, I'm lucky and I have access to a lathe, but there is other ways to go around it. You need to be able to find someone that can manufacture, I'll just take this apart, that can manufacture a prop hub. So all this is just actually it's just round rod aluminum, and all we've done here is we've stuck it in the lathe, we've made it the dimension we wanted, we've cut it down this way, and then what we've done is, you can see on this engine, is you see the little the shaft that's sticking out. I'm just gonna move this over here. Is we need to drill a hole in this end and then tap it for those threads. And then what we're going to do is we're going to flip it around in the lathe, and we're going to drill this end, and we're going to tap it for, this is a 3/8 bolt. This is a fine thread 3/8 bolt. Always use fine thread. It's a lot stronger than a coarse thread bolt is. There's more threads per inch. I mean, there's lots of people that are confused on that. They think coarse thread, bigger thread, stronger. It's not how the way it works. Fine thread is always stronger than coarse thread. So this is a fine thread 3/8. So I've tapped both sides. So this is where the prop goes. This is going to hold your prop on. And then this gets tightened onto the flywheel, which locks the flywheel in. And this now is allowing you to transmit to a propeller. So on this engine, on this one, I wanted a bigger shaft because this is going to be in a more scale type cowled airplane. So I needed the length to come out to get past the end of the cowl. This one's going to be for a fun fly. So I've made just a little simple one. So this is one that, I mean, most guys, if you could figure out in a drill press even where your center was, you could get this drilled down the center, because this one goes right through. See there? This one went right through. So I did this one on a lathe, but you could do this in a drill press. If you find the perfect center of this, you could drill right through the center and then step up to the size you need to drill for this. And then you can step it up to drill for the bolt. And what you do is this is just not even milled down at all. This is just a piece of that stock. And you thread it for this. So this will screw onto this one. And then you thread it for the bolt. And then that's what your prop hub is going to be. This one's nice and simple. This one is just a little guy. See how that's going to work? So that one, because I don't really need the space to stick the propeller out further from the engine, I can get away with this. So now that if we want more videos on this, I could probably make a video when I'm at the lathe turning one of these and going through the drilling and tapping and stuff, and then how it will mount. The next thing you need to do, if you have access to the lathe, or if you have a friend that has a lathe, it's a lot easier. You're gonna chuck this up, and then you're gonna remove all the flywheel fins. Okay, and there's a little spring arms that engage for when you pull the pull start. We don't need any of that stuff anymore, but don't touch this surface. This surface is what your prop adapter has to go on. It needs to be true. So do not mess with this. This engine, this is for a 33cc Homelite chainsaw engine. So this is one way to do it. You can use the lathe if you have access. I had access to it on this one. This one I was impatient for this 30cc, and I didn't use the lathe, and I wanted to show you why. You don't have to use a lathe. This one is just cut down with a hacksaw, and I cut everything off. It's a little bit more crude. And then what I did is, you can see here, since it's not perfect, I've went in here and I've removed some material to make it I'll still have to mess with it a little bit, but to get it so it'll balance. So all you're doing is just removing material from one end, whatever the heavy end is that falls. See, we're pretty close there. See, it's pretty close. It's just when I wind those wheels. So that's another way. You can use a hacksaw, but you need to balance these because they're pretty out of balance, and it will shake a lot. So once again, all I did is I just cut off, I kind of chucked it up in a vise, and I just went to town with a hacksaw cutting down, and then I just took a file and smoothed it out a little bit, and then I've just removed a little bit from the heavy spot. The magnet is the heavy spot on this one. So I started removing some. I used a die grinder too. I have one that will remove loom really nice. So I've used that, and I'm just going to fine tune it with a file now, just to get it so it's whatever position on the prop balancer here, it doesn't move. See, it's pretty close. You want to be able to set it anywhere, and it shouldn't it shouldn't move. See that? So that's another way to do it. Those two things are the things that people have a big problem with when trying to get these engines. Most of the other stuff people will figure out, and some of the other videos explain. These two things, the flywheel and the prop adapter, those are the two things that a lot of the videos, the comments are asking, how did you make this? How do you make the flywheel work? Everything else, there's write-ups and stuff like that on the internet. But just showing you guys that it doesn't have to be super complicated, okay? It's just a simple piece of aluminum that is drilled through the center, and it's just tapped on either end for 2 different pitches and 2 different sizes. And then you just remove some of the fins here. And then once we have it balanced and everything assembled, we'll bring you back for another video. And you can see what it'll look like in comparison to this engine. And we'll do some runs with some different props. And I'll show you how easy they are to hand start. Even without electronic ignition, these things are awesome. You don't have to struggle at all. They're just awesome. The other thing is the carb. I can do a video on these too if we want to. This one is the one that come off. This is an 11.1 millimeter. So this is the right size for a 30cc. If you want to try to get a little bit more power, you can use a little bit bigger carb. It'll be a 30 or 32 stamped in here. This one's a 24. But it won't be as nice of a transition from low to high, and you'll get a little bit more power on the top end, but the idle won't be very nice. So this one I've rebuilt. I've changed all the gaskets. I changed the pump and the metering diaphragm. That's all been changed. This line here is for the primer bulb. On these, we don't do that. We just run a single line. So if you look at this one's also plugged to the primer bulb. We only need one line on these gas engines, and this one goes to the carb. This goes to the pickup. Okay, pickup to here. This is blocked off because we're not actuating here. All we're doing is closing the choke, and we're spinning it over, and it'll suck fuel. Super simple, and yeah, never quits. Anyways, if there's any questions, you can leave them in the comments. I will try to make another video in the next few days after I get the cylinder and the piston and everything together on this. I'm going to put the back plate on it, and I'll get the flywheel, and then I'll put the prop adapter, and I'll get everything mocked up, and I'll bring you back maybe for one video just to kind of have an idea of what it looks like, how everything fit together, how I tightened everything. And then we'll have another video on it running, and stay tuned for that. Okay, have a good day. Thanks.